What is JavaScript? JavaScript is a high-level interpreted programming language used to make web pages interactive. It can handle user interactions, animations, and even back-end development with technologies like Node.js. Think about when you click a button on a web page and something changes without reloading the page, or when a form checks your details before submitting. That's JavaScript at work. History of JavaScript. JavaScript was created in 1995 by Brendan Eich while working at Netscape. Initially, it was called Mocha, then LiveScript, and finally, JavaScript. Over the years, it has grown into one of the most important languages in web development. Here's a quick timeline. 1995, created as Mocha. 1996, renamed JavaScript. 2005, the rise of Ajax for dynamic web apps. 2009, introduction of Node.js for backend development. 2015, ECMAScript 6, ES6 brought major improvements. 2024, JavaScript continues to evolve and power modern applications. Role of JavaScript in web development. JavaScript is one of the 3 core technologies of web development, alongside HTML and CSS. HTML structures the web page. CSS styles it. JavaScript makes it interactive. Without JavaScript, websites would be static and unresponsive. It enables everything from simple animations to complex web applications. How JavaScript works in browsers. When you write JavaScript code, your browser has a built-in JavaScript engine that reads and executes it. For example, Chrome uses the V8 engine, and Firefox uses SpiderMonkey. You can test this right now. Open your Chrome browser, press F12 to open Developer Tools. Go to the Console tab and type console.log hello JavaScript. Hit Enter, and you'll see the message appear in the console. Setting up the development environment. To start coding JavaScript, we'll use 2 tools. 1, the browser console, which we just saw. 2, a code editor like Visual Studio Code. To set up, download and install VS Code from code.visualstudio.com. Install Node.js from nodejs.org. Open a terminal and type node-v to check if Node.js is installed. Now you're ready to write JavaScript outside the browser too. Writing the first JavaScript program. Let's write our first JavaScript program inside VS Code. Create a new file called script.js and type this, JavaScript console.log hello world. Save the file, open a terminal, and run bash node script.js. If everything is set up correctly, you'll see hello world printed on your screen. Congratulations, you just wrote your first JavaScript program. JavaScript versus other programming languages. How does JavaScript compare to other languages? Compared to Python, JavaScript is faster for web development, but not as strong in data science. Unlike Java, JavaScript is not compiled, but is more flexible. JavaScript is easier to learn than C++ and is perfect for beginners. It's a versatile language that runs everywhere, on browsers, servers, and even mobile apps. Dive in. That's 1. Variables and data types. Declaring variables, var, let, and const. In JavaScript, we use variables to store data. There are 3 ways to declare variables. var. This is the old way of declaring variables. It has issues with scope, so we avoid using it. Let. This is the modern way to declare variables. It allows reassignment of values. Const. This is used for values that do not change. For example, let name equals John, const age 25. Var city equals New York. Here, name is declared using let, which means we can change its value later. Age is declared using const, meaning its value cannot be changed. And city is declared using var, but we should avoid using it in modern JavaScript. Best practice. Always use let and const instead of var to avoid unexpected bugs. Primitive data types in JavaScript. JavaScript has 7 primitive data types. 1. Number. Let x equals 42. 2. String. Example, let name equals Alice. 3. Boolean. Example, let is JavaScript fun equals true. 4. Undefined. When a variable is declared but not assigned a value. Example, let y. 5. Null. An intentional empty value. Example, let z equals null. 6. Symbol, used to create unique identifiers. Example, let sim equals symbol ID. 7. Big int, used for very large numbers. Dynamic typing in JavaScript. JavaScript is dynamically typed, which means variables can hold different types at different times. For example, JavaScript let value equals 10, value equals hello. No error. This means JavaScript automatically changes the data type of value from a number to a string. Be careful when changing variable types. It can cause unexpected bugs. Type conversion and type coercion. JavaScript automatically converts types in certain situations. For example, in the first case, JavaScript converts type into a number and performs subtraction. In the second case, JavaScript converts 2 into a string and performs concatenation. To manually convert types, we can use JavaScript let num equals number 123, converts string to number, lets t equals 56, converts number to string. 2. Operators in JavaScript. Arithmetic operators, used for calculations. Comparison operators, used to compare values. Best practice, always use equal instead of equal to avoid unexpected type conversions. Logical operators, used for logical conditions. Assignment operators, used to assign values. Ternary operator, shorthand for if-else statements. Conditions and loops, if-else, else-if statements, used for decision-making. JavaScript let num equals 10, if num 0, console.log positive number, else if num 0 to log negative number, else console.log 0. Switch statement, used when multiple conditions exist. JavaScript let color equals red, switch color, console.log stop, stop, break. Case yellow, console.log get ready, break. Case green, console.log go, break. Default, console.log invalid color. Loops in JavaScript. For loop, used when the number of iterations is known. 4. Let I equals 1, I equals 5, I plus plus, console.log iteration I. While loop, runs as long as a condition is true. JavaScript let count equals 1, while count 5, console.log count, count, count plus. Do while loop runs at least once, even if the condition is false. JavaScript let number equals 10. Do console.log number is plus number, number. While number 5. Break and continue statements. Break stops the loop completely. Example, JavaScript for let I equal 1, I equal 5, I plus plus. If I equals 3, break, stops the loop at 3. Continue skips the current iteration. If you found that a function declaration is the traditional way to define a function in JavaScript. It follows a simple syntax. We use the function keyword, followed by the function name, parentheses, and curly braces. Inside the curly braces, we write the function logic. For example, let's create a function called greet that prints a welcome message. Function greet, console.log, hello, welcome to JavaScript. To execute this function, we simply call it by its name, followed by parentheses, like this. Greet. Functions help us avoid writing the same code multiple times. Instead of repeating the same logic, we can define it once inside of a function and call it whenever needed. Now, let's talk about passing data into functions. We can use parameters to make functions more dynamic. For example, let's modify the greet function so that it can greet a specific user. Function greet user name. Console.log hello's name. Now, if we call greet user Alice, the output will be hello Alice. Functions can also return values using the return statement. This allows us to store the result of a function and use it elsewhere in our code. For example, let's create a function that adds 2 numbers and returns the result. Function addAB, return A plus B. Let sum equals add53, console.log sum. In this case, the function takes 2 numbers as input, adds them, and returns the result, which is then stored in the sum variable. If a function does not have a return statement, it returns undefined by default. Now let's move on to function expressions. In JavaScript, we can also define functions using expressions by assigning them to variables. For example, const multiply equals function AB, return A top B. We can call this function just like any other function. JavaScript console.log multiply 4, 3. The key difference between function declarations and function expressions is hoisting. Function declarations can be called before they are defined, while function expressions cannot. For example, this will work fine. JavaScript console.log square 5. Function square n, return n to n. However, this will cause an error. Console.square 5, const square equal function n, return n to n. This happens because function expressions are not hoisted like function declarations. Now let's talk about arrow functions, a feature introduced in ES6 that provides a more concise way to write functions. Here's how we define a function using arrow syntax. Const greet equals console.log hello world greet. If the function has only one parameter, we can even remove the parentheses. JavaScript const square equals num to num, console.log square 4. For multiple parameters, we use parentheses again. JavaScript const add ab equals a plus b, console.log add 3, 7. Arrow functions are great for shorter functions, but they cannot be used in all cases, such as when working with the this keyword in objects. Next, let's discuss default parameters. Sometimes we want to set a default value for a function parameter in case the user does not provide one. For example, function greet name equals guest, console.log hello plus name greet. Here, if no argument is provided, the function will use guest as the default value. Arrow functions also support default parameters. Const multiply equals ab equals 2 equals a cop b, console.log multiply 5. Since we didn't provide a second argument, b takes the default value of 2 and the output is 10. Finally, let's talk about callback functions. A callback function is a function that is passed as an argument to another function and is executed later. For example, function process user name callback, console.log processing user plus name callback. Function done, console.log user processed successfully, process user Alice done. Here, process user takes a name and a callback function. It logs a message and then calls the callback function, which prints user processed successfully. Callback functions are widely used in JavaScript, especially when working with asynchronous operations like fetching data from a server. In JavaScript, variables can have different scopes, meaning they are accessible only within a certain part of the program. A globally scoped variable is one that is declared outside of any function or block and can be accessed anywhere in the script. For example, here, global var is accessible both inside the function and outside of it. Now, let's talk about local scope. A variable declared inside a function is locally scoped, meaning it cannot be accessed outside of that function. For example, since local var is declared inside the function, it cannot be accessed outside of it. In JavaScript, the scope of a variable also depends on the keyword used to declare it. Function scope. In older JavaScript, variables declared with var have function scope, meaning they are accessible anywhere inside the function in which they are declared. For example, function scope example. If true, var x equals 10, console.log x, output 10. Function scope example. Even though x was declared inside an if block, it is still accessible outside of it because var is function scoped. Block scope. With let and const, variables are limited to block scope, meaning they are accessible only within the block in which they are declared. For example, function block scope example. If true, let y equals 20, const z equals 30, console.log yz, clash output 2030, console.log y. Error, y is not defined, block scope example. Here, y and z are declared inside the if block using let and const, so they cannot be accessed outside of it. In general, always prefer let and const over var to avoid unexpected behavior. Closures in JavaScript. Now let's discuss closures, one of the trickiest but most powerful concepts in JavaScript. A closure is created when a function remembers and continues to access variables from its parent scope, even after the parent function has finished executing. Let's break this down with an example. JavaScript function outer function, let count equals 0. Function inner function, count plus plus, console.log count, return inner function. Const counter equals outer function, counter. Output 1 counter, output 2 counter, output 3. Let's analyze what's happening here. 1. Outer function is called and executed. It creates a local variable count and defines an inner function inside it. 2. Instead of executing inner function, outer function returns it. 3. When we call counter, inner function still has access to count, even though outer function has already finished executing. This is the power of closures. They allow functions to remember variables from their parent scope even after the parent function has completed execution. Closures are widely used in JavaScript, especially in event handling, callbacks, and maintaining private variables. For example, closures can be used to create private variables like this. JavaScript function create counter, let count equals 0, return increment function, count plus plus, console.log count, decrement function, count, console.log count. Const counter equals create counter, counter.increment, counter.increment, counter.decrement. Here, count is private because it cannot be accessed directly from outside. The only way to modify it is through the increment and decrement functions. Started. If you found objects in JavaScript. In JavaScript, an object is a collection of key-value pairs. It allows us to group related data and functions together. Let's create an object representing a person. Const person equals first name John, last name Doe, age 30 is employed true, greet function, console.log hello, my name is this.firstname, this.lastname. Here, first name, last name, age, and is employed are properties, while greet is a method, a function inside an object. To access properties, we can use dot notation or bracket notation. Console.log person.firstname, output John console.log person age, output 30. To call a method inside an object, we use person.greet, output hello, my name is John Doe. Now, let's see how we can modify and add new properties to an object. Person.age equals 31, person.city equals New York, console.log person.age, output 31 console.log per city, output New York. We can also delete properties using the delete keyword. Delete person.isEmployed, console.log person.isEmployed, output undefined. Object destructuring. JavaScript allows us to extract specific properties from an object using destructuring. Const first name, last name, age equals person, console.log first name, output John console.log age, output 31. This makes it easier to access object properties without writing person.firstname multiple times. Introduction to arrays. An array is an ordered collection of values that can store multiple types of data. Let's create an array of colors. Const colors equals red, blue, green, yellow, console.log color 0. Output red, console.log colors 2. Output green. Arrays are 0 indexed, meaning the first element is at index 0. We can also modify, add, or remove elements. Colors 1 equals purple, console.log colors. Output red, purple, green, yellow. Colors.push black. Adds an element at the end, console.log colors. Output red, purple, green, yellow, colors.pop. Removes the last element, console.log colors. Output red, purple, green, yellow. Common array methods. JavaScript provides many useful methods to work with arrays. For each, the forEach method executes a function for each element in the array. Colors.forEach function color, console.log color. The map method creates a new array by applying a function to each element. Const uppercase colors equals colors map, color equals color.toUppercase. Console.log uppercase colors. Output purple, green, yellow. The filter method returns a new array containing elements that meet a specific condition. Const long colors equals colors.filter color length 4, console.long colors. Output purple, green, yellow. Find. The find method returns the first element that meets a condition. Const green color, colors.find equals color equals green. Console.log green color. Output green. The reduce method accumulates values in an array into a single value. Const numbers equals 1, 2, 3, 4, 5. Const sum equals numbers.reduce total num total plus 0. Console.log sum. Started. Selecting elements. Before we can manipulate elements, we need to select them. JavaScript provides several methods for this. Using getElementById. If an element has an ID, we can select it using getElementById. Const heading document.getElementByMain heading. Console.log heading. Logs the element with ID main heading. using query selector. The query selector method allows us to select the first matching element using CSS selectors. Const paragraph equals document.querySelector text selects the first element with class text console.log paragraph. If we need multiple elements, we can use query selector all, which returns a node list. Const all paragraphs is document query selector all text console.log all paragraphs. Logs all elements with class text. Modifying elements. Once we've selected an element, we can modify its content and styles. Changing content, inner HTML and text content. We can change an element's content using inner HTML or text content. Const heading document.getElementById main heading. Heading.innerHTML, welcome to JavaScript, changes the HTML content. Text content is similar but doesn't parse HTML. Heading.textContent equals strong hello strong. Displays strong hello as plain text. Changing styles. We can modify an element's style using style. Heading.style.color equals blue. Heading.style.font size equals 24px. Heading style.background color, light gray. Creating and removing elements. We can dynamically create and remove elements using JavaScript. Creating an element. To create an element, we use document.createElement, then set its properties and add it to the DOM. Const new paragraph equals document.createElement p. New paragraph.textContent equals this is a new paragraph. Document body append child new paragraph. Removing an element. To remove an element, we select it and use remove. New paragraph.remove. Removes the paragraph from the DOM. Alternatively, we can use remove child on its parent. Document.body.remove child new paragraph. Traversing the DOM. The DOM is structured as a tree, and we can navigate through it using different properties. Accessing parent elements. To get the parent of an element, use parent node or parent element. Const child element, document.querySelector.child, console.log child element.parent node, logs the parent element. Accessing child elements. To access an element's children, use child nodes, which includes text nodes, or children, which excludes text nodes. Const parent element equals document.querySelector.parent, console.log parent element.children, logs all child elements. Accessing siblings. To get an element's next or previous sibling, use next element sibling or previous element sibling. Const first child equals document.querySelectChild, console log first child.next element sibling, logs the next sibling. Handling click events. One of the most common user interactions is clicking on a button. To handle this, we use the add event listener method. Example. Const button equals document.querySelector my button, button.addEventListener click function, alert, button was clicked. Whenever the user clicks the button with the ID equals my button, an alert will pop up saying, button was clicked. We can also define the function separately and pass it to add event listener. Function handle click, console.log, you click the button, button.addEventListener click handle click, key down and key up events. We can detect when the user presses or releases a key using key down and key up events. Example. Document.addEventListener, key down, function event, console.log, key pressed event.key. This logs the key that was pressed. Key down triggers when a key is pressed. Key up triggers when a key is released. Example. Document.addEventListener, key up, function, event, console.log, key released, event.key. This is useful for cases where you want to trigger an action when the key is released, such as stopping a character in a game. Event delegation. Sometimes we want to listen for events on multiple elements without adding event listeners to each one. This is where event delegation comes in handy. Instead of adding event listeners to every child element, we add one listener to the parent and check which child triggered the event. Example. Document.querySelector.parentList.addEventListener click function event. If event target tag name equal li console.log, you clicked on event.target.textContent. This allows us to handle clicks on any list item inside parent list, even if new items are added dynamically. Preventing default actions. Some elements, like links and form submissions, have default behaviors that we might want to prevent. Example, preventing a link from redirecting. JavaScript document.querySelector. Tap mylink.addEventListener. Click function event.preventDefault. / stops the link from navigating console.log. Link clicked, but navigation prevented. This is useful when you want to handle the click manually, such as opening a modal instead of navigating away. Synchronous versus asynchronous JavaScript. JavaScript is single-threaded, meaning it executes one task at a time. Synchronous code runs line by line, waiting for each task to complete before moving to the next one. Console.log task 1, console.log task 2, console.log task 3. The output will always be task 1, task 2, task 3. Now let's introduce an asynchronous operation using setTimeout. Console.log task 1, setTimeout equals console.log task 2, delayed, 2000. Console.log task 3. Even though setTimeout is written before task 3, the JavaScript engine does not wait for it to finish. Instead, it moves on to the next line and prints task 3, while task 2, delayed, appears after 2 seconds. This is the core idea of asynchronous JavaScript. It allows certain operations to happen in the background without blocking the rest of the code. Callbacks, handling asynchronous code. A callback function is simply a function that is passed as an argument to another function and executed later. Example, using callbacks in asynchronous code. Function fetchData callback, console.log fetching data, setTimeout equal callback data received, 3000. Function processData data, console.log data, fetchData, processData. Here's what happens. 1. Fetching data is printed immediately. 2. setTimeout waits for 3 seconds before executing the callback function. 3. Once the time is up, data received is printed. Callback hell and its problems. When working with multiple asynchronous operations, callbacks can get deeply nested, making the code hard to read and maintain. This is called callback hell. Function step 1 callback. setTimeout equals console.log step 1 completed, callback 1000. Function step 2 callback. setTimeout equals console.log step 2 completed, callback 1000. Function step 3 callback. setTimeout.log step 3 completed, callback 1000. Step 1 equals step 2, step 3, console.log all steps completed. As you can see, the nested structure makes it difficult to read and maintain. What is a promise? A promise in JavaScript is an object that represents the eventual completion or failure of an asynchronous operation. Promises have 3 possible states. 1. Pending. The operation is still in progress. 2. Resolved, fulfilled, the operation completed successfully. 3. Rejected, the operation failed. Creating and consuming promises. Let's create a simple promise that simulates fetching data from a server. Const fetch data equals new promise, resolve reject, console.log fetching data. setTimeout equal let success equals true. Change to false to simulate an error if success. Resolve data fetched successfully. Else, reject, failed to fetch data, 2000. Now, let's consume this promise using .then and .catch. Fetch data.then data, console.log data, .catch error, console.error error. Here's what happens. 1. The promise starts executing and prints fetching data. 2. After 2 seconds, the promise either resolves success or rejects failure. 3. If successful, .then executes and prints data fetched successfully. 4. If an error occurs, .catch executes and prints failed to fetch data. Promise chaining. Promises allow us to chain multiple asynchronous operations without nesting callbacks. Example, fetching, processing, and displaying data. Function fetch data. Return new promise resolve equals setTimeout resolve raw data 2000. Function process data data. Return new promise setTimeout resolve processed data 2000. Fetch data then data console.log data received data. Return process data data. Then process data equals console.log process data processed data. Catch error console.error error error. Here's what happens. 1. Fetch data is called and returns a promise. 2. When resolved, the first .then receives raw data and calls process data. 3. Process data also returns a promise which resolves after 2 seconds. 4. The next .then receives processed raw data and logs it. 5. If any error occurs in the chain, .catch will handle it. Handling errors in promises. Errors in promises can be caught using .catch, but we can also use .finally, which runs whether the promise is fulfilled or rejected. Fetch data, .then, console.log, data, return process data. Then, process data equal console.log, process data. .catch error, console.error, error. .finally equals console.log, operation completed. What is async await? Async and await are keywords in JavaScript that simplify the syntax for working with promises. Using async functions allows us to write asynchronous code that looks and behaves like synchronous code. The async keyword is used to define a function that will always return a promise. The await keyword is used to pause the execution of an async function until the promise is resolved or rejected. Writing clean asynchronous code. Let's see how to use async and await to simplify asynchronous code. Example, fetching data with async await. Here's how you can fetch data using async and await. Async function fetch data. Let response equals await fetch https json placeholder.typicode.com/posts. Let data equals await response.json. Console.log data fetch data. In this example, 1. The async keyword makes the fetch data function asynchronous. 2. Inside the function, we use await to wait for the promise returned by fetch to resolve. 3. After that, we use await again to wait for the response to be converted into JSON format. 4. Finally, the data is logged to the console. The key takeaway here is that async await makes asynchronous code look synchronous, making it much easier to read and understand. Error handling with try-catch. When working with asynchronous code, error handling is crucial. With async await, we can use the try-catch block to handle errors in a clean and readable way. Example, handling errors in async await. Let's modify our previous example to handle errors gracefully. Async function fetch data. Try let response equals await fetch https placeholder.typicode.com/posts. If response.ok, throw new error. Network response was not okay. Let data equals await response.json. Console log data. Catch error. Console.error. There was a problem with the fetch operation. Error. Fetch data. In this updated code, 1. We wrap the await calls inside a try block. 2. If an error occurs during the fetch or response JSON operations, it will be caught by the catch block. 3. The catch block logs a friendly error message to the console, so we know what went wrong. This pattern ensures that errors are caught and handled properly, preventing the program from crashing. Let and const. Before ES6, JavaScript used var to declare variables. However, let and const introduced better ways to handle variable declarations. Let allows reassigning values, but is block scoped, meaning it's only accessible inside the block where it's defined. Const is also block scoped, but cannot be reassigned. It is best used for values that should not change. Example, let name equals John, name equals Doe. This is allowed const age equals 25, age equals 26. This will throw an error. Using let and const helps prevent accidental overwriting of variables and improves code maintainability. Arrow functions. Arrow functions provide a more concise way to write functions in JavaScript. Example, traditional function add AB, return A plus B. Arrow function const add equals AB, A plus B. Arrow functions make code shorter and more readable. They also inherit the this value from their surrounding scope, unlike regular functions. Template literals. Literals allow us to embed variables inside strings using backticks instead of quotes or. Example, const name equals Alice. Const message, hello, name, welcome to JavaScript. Console.log message. Output, hello Alice, welcome to JavaScript. This makes string manipulation much easier compared to traditional concatenation methods. Destructuring assignment. Destructuring allows us to extract values from arrays or objects and assign them to variables in a more readable way. Example, array destructuring. Const numbers equals 1, 2, 3. Const first, second, third numbers. Console.log first. Output, 1 console.log second. Output, 2. Example, object destructuring JavaScript const person equals name Bob, age 30. Const name age equals person. Console.log name. Output, bobconsole.log age, output 30. Destructuring makes working with objects and arrays more convenient. Spread and rest operators. The spread operator allows us to copy or merge arrays and objects easily. Example, spread operator. Const A equals 1, 2, 3. Const R2 equals AR1, 4, 5. Console.log AR2. Output 1, 2, 3. The rest operator is used in function parameters to collect multiple arguments into an array. Example, rest operator. Function sum.numbers return numbers.reduce axi num equal axc plus num 0. Console.log sum 1, 2, 3, 4. Output 10. The spread and rest operators make working with arrays and functions more flexible. Modules, import-export. JavaScript modules allow us to break our code into reusable files. Example, exporting a function from math.js. Export function add AB. Return A plus B. Importing in another file app.js. Import add from /math.js. Console.log add 510. Output 15. Using modules helps organize code better and makes it easier to maintain. Started. Handling errors with try, catch. JavaScript provides the try-catch statement to handle runtime errors gracefully. Syntax. Try. Code that might throw an error. Catch. Error. Code to handle the error. When JavaScript encounters an error inside the try block, it immediately jumps to the catch block instead of crashing the program. Example. Try. Let result equal 10/0. Console.log result. Catch. Error. Console.log an error occurred. Error.message. Since dividing by 0 doesn't actually throw an error in JavaScript, let's see a case where an error is thrown. Example, accessing an undefined variable. Try, console.log value. Value is not defined. Catch, error. Console.log an error occur message. Here, JavaScript throws a reference error because value is not defined. The catch block captures it, preventing a crash. The throw statement. Sometimes you may want to generate custom errors using the throw statement. This is useful for validating inputs or enforcing rules in your application. Example, throwing a custom error. Function check age. If age 18, throw new error. You must be at least 18 years old. Return access granted. Try console.log check age 16. Catch error console.log error their error.message. If the age is below 18, we throw an error, which is caught by the catch block, preventing program failure. Using the finally block. The finally block always executes, whether an error occurs or not. It's useful for cleanup operations, such as closing a database connection or logging actions. Example, try let num equals 5, console.log num to uppercase. This will cause an error. Catch error console.log an error occurred, error.message. Finally, console.log execution completed. Even though an error occurs, the finally block still executes, ensuring that necessary cleanup happens. Custom errors in JavaScript. Sometimes, built-in errors like type error or reference error aren't specific enough. You can create custom error classes to define your own error types. Example, creating a custom error class. Class validation error extends error constructor message, super message. This.name equals validation error. Function validate username. If username length 5, throw new validation error. Username must be at least 5 characters long. Return username is valid. Try console.log validate username Sam. Catch error console.log error.name error.message. Here, we created a validation error class that extends the built-in error class. This helps in categorizing different types of errors in large applications. Understanding APIs and JSON. An API acts as a bridge between different software applications, allowing them to exchange data. When working with APIs, data is often sent and received in JSON format. What is JSON? JSON, or JavaScript Object Notation, is a lightweight data format that is easy to read and write. It looks similar to JavaScript objects and is used to store and transfer data. Example of JSON data. Name John Doe, age 30, email john@example.com. In JavaScript, we use json.parse to convert JSON strings into objects, and JSON stringify to convert objects into JSON strings. Example, const JSON data equals name John, age 30. Const obj equals json.parse JSON data, console.log obj.name. the Fetch API. JavaScript provides the Fetch API to make network requests to retrieve data from APIs. Basic syntax: fetch hpi.example.com/data, then response equal response.json, then data console.log data, catch error console log error. At fetch sends a request to the given URL. The then response.json converts the response into JSON. The then data equal console.log data handles the retrieved data. The catch handles any errors. Making API requests. GET request fetching data from an API. A GET request is used to retrieve data from an API. Example, fetching data from a public API. Fetch JSON placeholder.typico.com/users. Then response equal response.then data console.log data. Catch error console.log error. This will fetch a list of users from the placeholder API and log it to the console. Handling API responses and errors. When making API requests, it's important to handle errors such as network failures, invalid responses, or server errors. Example, checking response status. Fetch JSON placeholder.typico.com/users, then response equal if response.ok, throw new error, HTTP error, status response.status, return response JSON. Then data console.log data, catch error equal console.log error.message. Here, we check if response.ok is false, which means there was an error, like 404 or 500, and we throw a custom error message. Post request, sending data to an API. A post request is used to send data to an API. This is useful for submitting forms or creating new records in a database. Example, sending data to an API. Fetch JSON placeholder.typico.com/posts, method post, content type application/JSON, body JSON.stringify, title hello world, body this is a test post, user ID 1, then response.json. Then data console.log created post data, catch error equal console log error. Here, we use method post to send data, set headers to tell the API we're sending JSON, use JSON.stringify to convert our object into a JSON string, handle the response and errors. Using async await for API requests. Instead of .then and .catch, we can use async await for a cleaner approach. Example, fetching data using async await. Async function fetch data. Try, let response equals await fetch https JSON placeholder at typico.com/users. If response.ok, throw new error, status response.status. Let data equals await response JSON, console.log data. Catch error, console.log error.message. Fetch data. This makes the code easier to read and avoids short callback hell. Local storage and session storage. JavaScript provides two main ways to store data in the browser. Local storage stores data permanently until manually cleared. Session storage stores data only for the session and is deleted when the page is closed. Using local storage. To store data in local storage, we use the local storage.setItem method. Local storage.setItem username John Doe. To retrieve stored data, we use local storage.getItem. Let user equals local storage.getItem username console.log user. Output John Doe. To remove a specific item from storage, use local storage.removeItem. Local storage.removeItem username. To clear all stored data, use local storage.clear. Using session storage. Session storage works similarly, but only lasts as long as the browser tab is open. To store data in session storage.sessionuser Jane Doe. To retrieve data, JavaScript lets session user equals session storage.getItem session user, console.log session user. Output Jane Doe. To remove an item, session storage.removeItem session user. To clear all session storage.clear. Cookies in JavaScript. Cookies are small pieces of data stored on a user's computer. They are often used for authentication, user preferences, and tracking sessions. Creating a cookie. We can create a cookie using document.cookie. Document.cookie equals user equals John Doe, expires equals Fry, 31st of Dec 2025, 2359 GMT, path equals /. Here, user of John Doe is the key value pair. Expires sets the expiration date. Path equals / makes the cookie accessible across the site. Reading cookies. To read cookies, use document.cookie. Console.log document.cookie. This returns a string with all cookies stored in the browser. Updating and deleting cookies. To update a cookie, simply overwrite it with a new value and expiration date. Document.cookie user at Jane Doe. Expires equals fry 33rd 25 2359 GMT /. To delete a cookie, set the expiration date to a past date. Document.cookie user gets expires the 01st Jan 1970 UTC. Path equals /. Storing and retrieving data efficiently. When deciding between local storage, session storage, and cookies, use local storage for long-term storage of user preferences or settings. Use session storage for temporary data that should be cleared when the session ends. Use cookies when you need to store data that should be sent to the server with every request, like authentication tokens. Started. JavaScript was originally designed for small scripts running on web pages. As applications grew more complex, developers needed a way to organize code better. This is where JavaScript modules come in. Modules allow us to break our code into smaller, reusable files, making it easier to manage, debug, and scale. Understanding JavaScript modules. A module is simply a file that contains reusable JavaScript code. Each module can export specific parts of its code, and other files can import them when needed. This modular approach helps in avoiding global namespace pollution, improving maintainability, enhancing reusability. Exporting and importing modules. Exporting in JavaScript. There are two ways to export code from a module. 1. Named exports. 2. Default exports. Named exports. Named exports allow multiple values to be exported from a file. Let's say we have a file named math.js. Export const add equals a, b equal a plus b. Export const subtract equals a, b equals a minus b. Here, we are exporting two functions, add and subtract. To import these functions into another file, import add subtract from /mathjs console.log5 3. Output 8 console log subtract 10 4. Output 6. If needed, we can also rename imports using as. Import add as sum, subtract as minus from math.js, console log sum 5 3, console.log minus 10 4. Output 6. Default exports. A default export allows a module to export one primary value. Example in greet.js, export default function greet name, return hello name. To import a default export, we can use any name. Import greet from /sol.log greet Alice. Output hello Alice. A module can have both named and default exports at the same time. Introduction to Webpack. When using modules in large projects, we often end up with many JavaScript files. To efficiently manage and optimize these files, we use module bundlers like Webpack. What is Webpack? Webpack is a JavaScript bundler that takes multiple JavaScript files, bundles them together, and optimizes them for better performance. It helps in reducing the number of HTTP requests, minimizing file sizes for faster load times, supporting modern JavaScript features across all browsers. Setting up Webpack. To use Webpack, follow these steps. 1. Install node.js and npm. Download and install Node.js from nodejs.org. Check the installation by running node-v npm-v. 2. Initialize a new project. Run the following command in your project folder. npm init-y. 3. Install Webpack and Webpack CL. npm install Webpack, Webpack CLI-save dev. Create a Webpack configuration file. Inside your project, create a file named webpack.config.js and add const path equals require path, module.exports equals entry /ins.js, main entry file output, file name bundle.js, path resolve dir name dist mode development. 5. Run Webpack, npx webpack. This will bundle all JavaScript files into a single bundle.js file inside the dist folder. What are JavaScript frameworks? Imagine you're building a house. You could start from scratch, lay every brick, wire every light, install every pipe. Or you could use a ready-made blueprint with structures and systems already in place. JavaScript frameworks work the same way. They provide a pre-built structure and set of tools for developing web applications faster, more efficiently, and with best practices already built in. Instead of writing everything from the ground up, frameworks allow you to focus on your app's logic and features, while they handle the heavy lifting, like updating the user interface, managing data flow, and routing between pages. Let's look at some of the most popular JavaScript frameworks and libraries: React, Vue, and Angular. First, React. React is a JavaScript library developed by Facebook. It's used for building fast, interactive user interfaces, especially single-page applications. React is component-based, which means you build your UI using reusable pieces of code called components. It uses something called the virtual DOM, which makes updates really fast and efficient. React has a massive community, lots of job opportunities, and is great for both small and large-scale projects. Next, Vue.js. Vue is a progressive JavaScript framework that's super beginner-friendly. It's known for being lightweight, simple to integrate, and easy to learn. Vue also uses a component-based approach similar to React, and it offers powerful tools like reactive data binding and built-in animations. It's perfect for both quick prototypes and full-scale applications. And then we have Angular. Angular is a full-fledged framework developed by Google. It comes with everything out of the box: routing, state management, form validation, and more. It uses TypeScript by default and follows a more opinionated and structured approach. Angular is great for enterprise-level applications, where scalability and maintainability are key. Now the big question is, when should you use a framework? If your project is simple, like a static website or a basic form, you might not need a framework at all. Vanilla JavaScript, HTML, and CSS can get the job done. But if your project has multiple interactive components, dynamic data updates, complex state management, or needs to scale over time, then using a framework can save you time, reduce bugs, and make your code more organized. Choosing the right framework depends on your needs. React is great for flexibility and large communities. Vue is ideal for simplicity and ease of learning. Angular offers a powerful all-in-one solution for complex applications. We'll go through 4 beginner-friendly projects that will help you practice what you've learned and strengthen your skills. Let's begin. First up is the To-Do List app. This is a classic beginner project that teaches you how to add, edit, and delete tasks, store them in local storage, and dynamically update the user interface. You'll learn how to work with arrays, handle form inputs, and use event listeners to make your app interactive. It's also a great introduction to DOM manipulation and local storage. Next, we have the calculator. Everyone's built one, and for a good reason. This project helps you practice handling user inputs, performing arithmetic operations, and updating the screen in real time. You'll use conditional logic, switch cases, and string manipulation. By the end, you'll have a fully functional calculator that looks and feels like a real one. third is the stopwatch. This one teaches you how to use JavaScript's timing functions, like setInterval and clearInterval. You'll build a start, stop, and reset functionality and display the time on screen with precise formatting. This project sharpens your understanding of how JavaScript handles time and asynchronous events. And finally, the Weather app, a step up in complexity because it involves working with APIs. You'll use the Fetch API to get real-time weather data from an external source like OpenWeatherMap. Then, you'll learn how to handle API responses, extract data from JSON, and display the weather information dynamically on the screen. This project gives you hands-on experience with asynchronous JavaScript, error handling, and integrating third-party data. These small projects might seem simple, but they're powerful building blocks. Each one teaches you a different aspect of JavaScript, from working with the DOM to handling events and making network requests. Now that you've built some small JavaScript projects, let's level up a bit. In this lesson, we'll look at 3 medium-level JavaScript projects that will push your understanding further. Let's dive in. First up is the notes-taking app. This app allows users to write, save, view, and delete notes. You'll create a user-friendly interface where notes can be added with a title and content.
Next, we have the expense tracker. In this app, users can enter their income and expenses, categorize them, and see the total balance.
Finally, the quiz application. This project is both fun and educational. You'll build a multiple-choice quiz where users answer questions, get feedback, and see their final score. These medium projects are a perfect bridge between beginner exercises and full-scale applications. They encourage better code structure, introduce new challenges, and deepen your grasp of JavaScript fundamentals. Keep practicing, and I'll see you soon.